Good day, children. Welcome back to another wonderful lesson of math. Today we're talking about the greatest common factor. The greatest common factor. And what greatest common factor is? Greatest common factor is kind of what it sounds like. It's the factor that is the biggest that is in common in two or more numbers. So the greatest common factor, or the GCF, this is the greatest whole number that divides evenly into two or more whole numbers. All right, the greatest common factor is the greatest whole number that divides evenly into two or more whole numbers. All right, so one way that we can do greatest common factor. If I said, hey, I want to know the greatest common factor, the GCF of 24, 36, and 48. I don't know, what's the greatest common factor of these three numbers? Well, I would look and say, all right, well, let's make some lists. Let's write out all of the factors of 24, all of the factors of 36, and all of the factors of 48. Well, 24 is going to start with 1, 2, 3, 4, 6, 8, 12, and 24. Those are all the factors of 24. Now I could say, okay, well, what about 36? Well, 36 would be 1, 2, 3, 4, 6, 9, 12, 18, and 36. Those are all the factors of 36. Those are all the numbers that multiply together to get 36. I could go even further and say, okay, well, what are the factors of 48? Well, 48, I have 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And those are all of my factors of 48. Okay, so lots of factors here. Now I want to say, all right, well, what factors are in common in all of these options? Okay, well, I have the factors of 1, 2, 3, 4, 6, 8 is in common here and here, but it's not in common in 36. 36 cannot be divided by 8, so that's not a common factor. But 12 can be in all of these. And then over here I have a 24 and a 24, but since it's not in common in 36, it doesn't count. So it looks like our greatest common factor, the biggest number that's in common in all three of these numbers here, is 12. So I could say, all right, my greatest common factor is 12. This is one method to find greatest common factor. This way works if you have a lot of time on your hands and you're really good at knowing all of your factors of all of your numbers, and you feel like you want to write out big lists and compare and you won't make any mistakes. If you're not that one person in the world who thinks they know all the factors of all the numbers and can do them all without making any mistakes, another method that you might use would be using prime factorization. Okay, so we're going to use prime factorization on these same three numbers, 24, 36, and 48, And we're going to see what we can do once we know the prime factorization of these three numbers. All right, so 24. Let's do our little factor tree over here. 24 breaks down into 2 and 12. 2 is prime, so we circle it. 12 breaks down into 3 and 4. 3 is prime, so we circle it. 4 breaks down into 2 and 2. And those are both prime, so we circle them. So 24 gives us 2 times 2 times 2 times 3. And that's 24. 36 breaks down into 6 and 6. And both 6's break down into 2 and 3 and 2 and 3. I don't know what that 2 is, don't ask, but it's a 2. So 36 breaks down into 2 times 2 times 3 times 3. And then finally we have a 48. 48 breaks down into 6 times 8. 6 is 2 and 3. 8 is 2 and 4. And 4 is 2 and 2. Lots of 2's here in a 48. 48 breaks down into 2 times 2 times 2 times 2 times 3. All right, that is our prime factorization of the numbers. Now, this lesson is called Greatest Common Factor. We're going to be looking for commonalities within these three prime factorizations. Well, we can see each of these prime factorizations has a 2 in it. Let's circle those. Each of these prime factorizations has another 2 in it. Let's circle those. Each of these prime factorizations have a 3 in it. Let's circle those. Now, is there anything else in common between these three prime factorizations? 24 has a 2, but 36 doesn't have any more 2's. 36 has a 3, but nowhere else has a 3. 48 has a couple more 2's, but again, 36 doesn't have any 2's, so the 2's can't be in common anymore. Tutankhamun, that's a little history joke for you. It was not great. I didn't set it up well. My bad. I'm sorry. Ignore what I just said. All right, so 2, 2, and 3. Now, what we do with this is we take each of these groups, and each of these groups become one number down here. So all of these 2's are going to combine to be a 2, times all of these 2's are going to combine to be another 2, times all of these 3's are going to combine to be a 3. So each group, we're going to make each group into one value, and then we're going to multiply all of these together to say 2 times 2 is 4. 4 times 3 is 12. And that is the greatest common factor. Wow, we really just kind of went quite a ways there. That was a lot of work we just did. A lot of talking. I know I went kind of fast on that one, but that is how this works. So we find our prime factorization, we circle the things in common, and then we multiply those common numbers, and that will give us our greatest common factor. So if you see, both ways gets us 12. We get a 12 here, we get a 12 here. One of these ways involves making big long lists of all the factors, hoping we didn't forget any. One of our ways does our prime factorization and looks for things in common. Both ways work. Whichever way you want to do, I'm totally okay with. I just want to make sure you're doing it well. All right, let's try another example. I'm going to stick with the prime factorization one, but we're going to try another one and see how things go. Let's say I want the prime factorization of, let's say 60 and 45. I want the greatest common factor of 60 and 45. So we want to break these down into their prime factorizations. 60 and 45. 60 breaks down into 6 times 10. I like these 0 ones. It always gives me a times 10. 6 breaks down into 2 and 3. 10 breaks down into 2 and 5. Great, so 60 is 2 times 2 times 3 times 5. Do you see why it's good to put these in order, to put our prime factorizations in numerical order? It helps us to be able to identify things in common when we put them in numerical order. All right, now let's deal with 45. See what we get with 45 here. We get a 45. 45 breaks down into 5 times 9. 5 is prime, so we leave that. 9 breaks down into 3 times 3. Those are both prime, so we circle them. We have 3 times 3 times 5. We're going to look for those numbers that are in common here. We get a 3. We get a 5. And nothing else, so this becomes 3 times 5, which equals a greatest common factor of 15. All right, 15. Now, for one final challenge in our lives, we are going to, before you leave today, you are going to find me the greatest common factor of 60, 96, 132, and 504. Good luck, children. I will see you all tomorrow. Have a great rest of your day.